So students, this is the first application we are going to do of the properties of the parallelogram. If the diagonals of a quadrilateral bisect each other at right angles, prove that it is a rhombus. First of all, what is a rhombus? You all know about this. What is a rhombus? I am saying once, that is the quadrilateral whose four sides are equal, or you can say the parallelogram whose four sides are equal is called a rhombus. It is correct. That is a parallelogram whose four sides are equal is called a rhombus. Now, first of all, it is given, see this line, if the diagonals of a quadrilateral bisect each other. From the properties of the parallelogram, we can definitely say then this quadrilateral is a parallelogram. I am writing like that. Since the diagonals bisect each other, then obviously it is this quadrilateral is the parallelogram. So, first of all, we have told that is this quadrilateral is a parallelogram. So, whenever we have told this one, then we are very much sure about that we can apply the properties of the parallelogram here. Okay. Now, secondly, bisect each other at the right angles. Now, the time to draw the figure. Here, you have to prove the rhombus, so draw a rhombus here. And the diagonals are here, so draw the diagonals also. Give the names A, B, C, D and here O. It is given. What it is given? The diagonals are bisecting each other at first. So given AO equals to OC and BO is equals to OD. Secondly, what it is given? Bisect each other at right angles. So obviously those angles, the middle angles, those are the right angles here. Also the angle AOD is equals to angle COD is equals to angle AOB is equals to angle BOC is equals to 90 degree. All the angles are 90 degree here. To prove it is a rhombus. That means I have told the definition of the rhombus. It is that is the sides. All the sides will be equal. For a parallelogram, if all the sides are equal, then it is called the rhombus. So to prove it is a rhombus, that is AB equals to BC equals to CD equals to DA. We have to prove this one only. Okay. So students, let us take now the proof. You can give the definition and description of the figure here. I am not giving description. Okay. So now the proof. For triangle AOD and triangle COD, those two triangles, this and this, we are taking. So what it is said, first of all, AO is equals to OC, it is given. Secondly, OD is common, OD equals to OD, the common side, and angle AOD is equals to angle COD is equals to 90 degree. It is also given. So by SAS property, or congruence, we can say triangle AOD is congruent to triangle COD. So whenever those are congruent, then obviously obviously we can say by CPCT AD is equals to CD. This side is equals to this side we have got. Now, by similar property, similarly we can say okay, directly we will use the property of the parallelogram. Just see, here we have got AD equals to CD. Also, AD is equals to BC and AB is equals to CD. Why? Because this is the parallelogram. It is I have told here. At the very first of the theorem, I have told that is this is the parallelogram because the diagonal bisect each other. That is the property of the parallelogram. Now, in the reverse way, if it is the parallelogram, if ABCD is the parallelogram, then we can definitely say that is AB is equals to CD and AD is equals to BC. That is the property of the parallelogram. Just see, that is the opposite sides are equal. So here I am writing here, since ABCD is the parallelogram. Now, we have got AD is equals to CD. Again we are getting AD is equals to BC and AB is equals to CD. So obviously from those two, number 1 and number 2, we can conclude that from 1 and 2 we can definitely say AB equals to BC equals to CD equals to DA. That means ABCD is the rhombus. So very easy proof. Just you have to apply the results of the or the properties of the parallelograms in a right way, then you will get this proof. So students, pen this proof. Just we'll extend one line here and then we'll show the extra proof. Actually this type of question comes, that's why I am saying that is further diagonals are equal, prove that it is a square. That is one condition I have joined here. That is the diagonals here also I am saying those diagonals are equal here. At the previously what it is written, if the diagonals of a quadrilateral bisect each other at right angles, prove that it is a rhombus. Up to this the diagonals are not said that those are equal. But here I am saying that now consider the diagonals are equal, then prove that this quadrilateral is a square now. Not only the rhombus, it is a square. So what's the definition of the square? A square means a parallelogram whose all sides are equal and also one angle is 90 degree. That is the square. Also from rhombus you can say, for the rhombus, if one angle is 90 degree for the rhombus, then we can say the rhombus is a square. So here just extra something we have to prove. This question comes, you have to do all of these. First of all, prove all of these. Okay. After that, what you have to do? Now, I am just joining the extra thing what you have to do if the question comes in such a way. So now, for triangle ABC and ABD, ABC and triangle ABD. Actually then the figure will be in such a way, that is just the angle will be the right angle. A, B, C, D and this is O. then it is those are the right angles. Actually not the right angles, we are just taking this one, the figure, because we have to prove it is a square. So now for triangle ABC and ABD, ABC and ABD, AB is common. Okay, now AC equals to BD, AC equals to BD. Here the diagonals are equal, that's why I have taken here AC equals to BD, it is given. And lastly, we can say that is AD is equals to BC. AD is equals to BC. We have already proved this one. Here it was. AD is equals to BC here. Or you can say given also, no problem. So from here we can conclude triangle ABC is congruent to triangle ABD. So by CPCT we can say angle BAD is equals to angle ABC. So those two angles are equal, I have told here. But also I am just erasing this part now, otherwise I cannot complete. Now angle BAD plus angle ABC equals to 180 degree. This is the rule of the quadrilateral. So angle BAD equals to 90 degree equals to angle ABC from this, because those two, the sum of those two angles is 180 degree, also those two angles are equal, so obviously those are the 90 degree angles. So whenever we have proved this is the 90 degree angle, then and there we can say the quadrilateral is a square. So ABCD is a square. So students, I think you have understood how we have done this one. First of all, originally it was up to this, that is you have to prove that it is a rhombus. Now for proving the rhombus it is a square, you have to must show that is one angle is 90 degree. So how to show? Just take the two triangles here, I have taken here ABD and ABC, those two triangles, and prove that those are congruent. After that, if you have proved those are congruent, then by CPCT we can definitely say those two angles are equal. So whenever those two angles are equal, by the property of the quadrilateral also, the sum of those two angles is 180 degree. So obviously sum of equal angles is 180 degree. So individually those are of 90 degree. So when those are of 90 degree, definitely the figure will be like this and it is a square. So students, jot down this theorem, very important theorem for your exam. So jot down this one, and also you have to see the Adesagoral book. There are lots of theorems are there like that, the small theorems. So students, up to this today, and we'll meet at the next video. So thank you.